let's just start our journey, right? Today is the first day of our journey, and we have 120 days. We will meet in every week at this time, uh, and we will discuss all the A-level syllabus, right? Let's start the first day. So in the first day, I will going to tell you what are the contents in the physics syllabus, in the advanced level of physics syllabus, and what you need to cover, right? Let's get into the first we can see the syllabus, right? So if there are 11 uh, lessons in physics A levels, right? The first lesson is mechanics, right? And the second lesson is I will write down the all 11 lessons, and I will discuss one by one in few minutes, right? The first lesson is mechanics, and the second lesson um, is the uh, oscillations and waves. There is another lesson here that calls measurements, but in my uh, lesson series, I'm not going to talk about measurements first, right? Maybe I will talk in the as the last session, right? There's a lesson called measurements, right? Measurements. So uh, maybe you have learned this a lot, but this is a not important one, right? Because there are a lot to learn. This is just like one or two, like very few marks in the exam paper. So we're not going to talk about this at this moment, but maybe in the future at the last lessons I will talk about this, right? The first one is mechanics in my lesson series, right? Not the actual syllabus. Right. So the second one is oscillations and waves, right? Okay, so we're going to talk about oscillations and waves, right? Okay, so this is the second part, right? Right. And the third one is, right? Third one is thermal physics, right? This is the order in your syllabus, right? But I'm not going to talk, I'm not going to teach you in this order. I will tell you the order in some minutes, right? Okay, so the uh, fourth one is gravitational fields. There are three fields we're going to talk about, right, in the A levels. The lesson is the lesson is fields, actually, right? Fields. So there are three fields in this one. Uh, First one, electric fields, and then we have to talk about gravitational fields, and also we have to learn about magnetic fields, right? Right. So those are the fields that we have to learn, right? So in the fifth lesson, but there are three lessons, right? So let's a number like this is five, and there is six, right? And seventh lesson is current electricity, right? So there is actually electricity, right? So the eighth one, right? Eighth one is electronics, right? Electronics, right? So those are the first eight lessons, right? And the ninth one is mechanical properties, right? Mechanical properties of matter, right? Right. And the tenth one is uh, matter and radiation, right? Right. So those are the lessons. There are 11 lessons, but I just neglect this one, so there are 12 lessons. And if we write down it as 11, that is measurements, right? Right. So those are the 11 lessons that we are going to learn in this lesson series, right? So at the first, I will do this one, right? So this is the first one we're going to talk about. And secondly, we talk about thermal physics, right? And then we talk about electricity, right? And next, we're going to talk about fields, right? So after that, we're going to talk about matter and radiation. So that is the fifth one. And next, we're going to talk about mechanical properties of matter. And finally, we're going to talk about electronics. And finally, we're going to talk about measurements if we have time, right? Okay, right. So this is right. So at the first, I'm going to talk about mechanics, right? So before you learn mechanics, you have to know what is mechanics, right? So what is the mechanics, and what are we going to learn in the mechanics topic, right? So that is very important, because if you know these things, you can get better idea, right? So let's talk about what is mechanics, right? So in the mechanics, we're going to talk about main few things, right? First one is the motion in what? Straight line, right? So this is the first thing we're going to learn about, right? And secondly, we're going to learn about in circular lines, right? So whole circular motion, right? And the rotational motion, right? So these are the first things we're going to learn about, right? So then this is the motion, right? So in parallel to the motion, we're going to talk about forces, right? Because motions are actually kind of a results of forces, right? uh, and we're going to talk about motion, sorry, forces, right? And other than that, we're going to talk about work, energy, and power, right? So this is a separate one. And this is first one we're going to talk about, and this is also we're going to talk about parallel, uh, maybe after the straight line, right? And the third one is, and uh, other than that, in this mechanics topic, we're going to learn about hydrostatistics, right? Hydrostatistics and fluid dynamics, right? And those are the things, right? Okay. Before I explain mechanics, I'm going to tell you about these 11 lessons very briefly, like right. Measurements is like we learn how to measure things, right, using different type of tools, like how to measure the length, how to measure the width or something like that, right? Or thickness or something like that, right? Those are the things. So this is about how to measure things, right? So measurements is about how to measure things, right? Right. So oscillations and sorry, mechanics, right? In the mechanics, we're going to talk about actually the physical things, classical mechanics, right? Right, these things, right? Hydrostatistics, fluid dynamics, how fluids work, how motion work, how forces work, how work, energy, power is working, like that, right? So those are the things we learn in mechanics. And oscillations and waves is like vibrations, right? We're gonna learn about vibrations and waves. Maybe you have heard about sound waves, or maybe ultrasonic waves, right? Maybe so many things about oscillations, right? Maybe you have seen this one, the simple pendulum, something we used to make hallucinations, right? Maybe you have seen these things, right? Okay. Thermal physics. Thermal physics is about it is about a favorite thing, right? What is like ice creams, yeah, not only about ice creams, but we can talk about how many minutes we can keep an ice cream outside the fridge, right? So those things are called, and those things are talked in thermal physics, right? So how heat work, right? Like that. What is going on with heat, right? So that is the thing we normally learn in thermal physics, right? So in the fields is very different thing. Um, it is like we cannot see in normal see or touch or something. We cannot feel it, right? I mean, we can feel it in some ways, but in normal life, we don't actually know these things. There's a field we don't know, we don't detect it, right? We cannot detect it with our senses, right? I mean, not electronic senses, right? I mean, natural senses, right? Our five senses, we cannot detect these things very easily. We can, but not very easily, right? Like we can feel the heat, but we cannot feel the electric field, right? So there's the point I'm talking about, right? So in the electric field, but we can feel the gravitational field, right? Right. Also, magnetic field, we can, because in our childhoods also we have seen so many magnets, and we have played with them, right? So magnets are like that. Magnets, we have some experiences with magnets, right? So magnetic field is about magnets, and more than a little bit, right? um, and the current is like electricity, right? We know electricity from the day we were born, right? So we know that very well, but we don't know how it works, right? How current works, what is going on inside the wires, right? So that is the thing we are going to talk about in current electricity. And the electronics. So electronics means maybe you have bought the newspaper called Vijay, right? So maybe you have seen that the circuit page, right? Okay, so maybe you have worked around it, and you have some experience about circuits, right? So electronics is all about circuits, right? So how we build circuits, how we identify what's going inside the circuits, right? And those are the things in electronics, right? Um, in this chapter, I mean, in this A level electronics, we don't talk about very deeply, but we just talk about the fundamentals of electronics, right? And the mechanical properties of matter. So, in mechanical properties of matter, we actually learn about the some properties, right, in matter, right? Um, like viscosity in the liquids, right? Like that, right? We're gonna learn about main properties of the matter, right? And the matter and radiation. This is about radiation physics, right? Nuclear physics, like that, right? So maybe you have heard about PET machines, or maybe you have heard about um, like radiation, right? Maybe the Fukushima, Nagasaki, the accidents, right? And in the Nagasaki, the atomic bomb, right? So these are the things. I mean, this matter and radiation is the basic theory behind that, right? So we're gonna learn about how these bombs are working, and how actually I'm not promoting bombs, right? But we're gonna learn about the fundamental things inside these nuclear things, right? And how these nuclear missiles are working, the popular topic this time, right? And how nuclear facilities, nuclear electricity, power stations are working. So much things, right? And what happened in cancer treatment machines, like cobalt machines, like those things, right? So when you in normal life, we say like we're going for electric treatment, right? So but it is a radiation treatment, right? Yeah, when someone has a cancer, they go for electric treatment, right? But that is a radiation treatment, right? So we're going to learn about those things, right? um, right. So finally, measurements, I talked about this, right? Okay, so these are the things we're going to learn. And if we go into mechanics now as the first day topic, in the mechanics we're going to learn about fluid dynamics, work, energy, power, force, motion, and hydrostatics, right? So in first and in this mechanics, the first topic we're going to talk about is motion, right? So let's get into the motion, right? Okay, the first one is okay. Other thing is, I'm going to tell you now how we going to learn these things, right? Actually, this is an exam now, so we have to learn in a particular way that is good for the exams, right? So this is exam, so you have to be tough and you have to work hard, right? Uh, Otherwise, you can use your so much time to learn these things and get interested and find out a lot of things, a lot of newses and a lot of news and a lot of things, right? But uh, learning for an exam, that is different, right? So learning for an exam is something different than learning normal physics, right? So in here we will follow uh, like very special system to get an A pass in A levels, right? So if you follow this correctly and you will, if you do correctly what I'm saying to do, right? Uh, there's a better chance and great chance to get an A, right, for physics, right? So there are 4 months, so you have 120 days, right? I will cover the syllabus before the August month, right? So every week you will have 1 or 2 lessons, right? I will tell it later. So in these lessons, I will cover all the syllabus, right? All the important parts. I mean, all the lessons, but maybe some are not covered. Some will not cover, but it's not a problem, right? I will cover all the 11 lessons and all necessary things, right? For a, right? Because for a, you don't want to get 100, right? You only going want to get 75, but try to do your best, right? Right. So let's talk about the things we are going to do, right? So first one, we're not going to talk about theories, right? We talk about theories, but we don't make notes, right? This is a very speed theory class, so we don't have time to do notes, write down notes. No, we don't have. And this is 2026, so you have notes everywhere, right? You can get notes from internet. You can get notes from everywhere. You can see lessons on YouTube, anything. But here I'm guiding you to do the exam, right? I'm not gonna give you notes, right? I'm just gonna give you special, well planned system that if you want to get an A, you have to follow that, right? So if you follow that, you will get an A, right? So um, the first thing is that I'm gonna give you a special system. That system is correction based learning system, right? So in this one, I'm gonna give you corrections one by one. You have to um, do all the corrections, and at the end of the corrections, you will familiar with the theories, and you will be able to do the exam corrections, right? So every chapter, I will give you corrections, and you have to follow those corrections, right? If you are joining me with online, you can do it now with me. Or if you are watching this one using recording, just do with the recording, right? Right. So, however, you have to do all the corrections, and at the end, I will give you the corrections to do in the home during the work. There's a second one, homework, right? So these homeworks are very special system. I will cover I mean, not every, but most of lessons every week, right? I mean, no, I'm not going to give you homeworks from today's lesson only, right? I'm going to give you homeworks from all the lessons as possible, so you will not forget any lesson, right? So um, every week I will give you 20 to 30 questions. So you have to do these things in home, right? Before next day, right? So um, you can get the tunes from the Telegram group, right? You have to join it. If you don't know how to join it, um, you can contact me, right? Um, right? You can contact me using my number. Maybe I can write it here: 947132767114, right? So using this number, you can join. You can message me and request the tunes, right? If you are following my course, right? Okay, so these are the most important things. Homework. These homeworks are given by me using the tunes, right? So you have to find the number that I give and try that question. So that is the system. And the first one is question based learning. So I will give you questions, and at the end I will give you homeworks, right? So those are the plan for now. But in the mid of the course, I will tell about the model papers, right? So you have to face more than 10 model papers. I will give you. You can practice them, and I will mark them personally and give to you if you do, if you want, right? Right. So those are the things, but I will explain about the model papers later, right? Okay, so these are the things I have to tell you. So the thing is, actually, the thing is, you have to do whatever I say, right? So that is the brief idea of this, right? So I mean, in the class, whatever I say to do, you have to do that. So because it's affecting your results, right? So you have to do those things. If you do those things, you can get an A for sure, right? So try to be your best, work hard, but I mean not restless, right? Keep take your rest, make good sleep, right? But you have to avoid a lot of things, right? Uh, Something affecting your results, I mean in bad way, so you have to remove that from your life, right? Actually, if you can't remove, just post it, right? Then you can resume it after the LS, right? So if you are addicted to some thing, you have to pause it or you have to remove it, right? Because this is a very hard work, because this is a 2 year exam and you are at the end of it, right? So you have only like 4 months, and if you play in these 4 months, you will be regret about that, right? So you have to work hard in these 4 months, and you have to get the best results that you can get, right? So in this 4 months, you have to work every day, right? Not today and just off. No, you have to work every day, again and again and again. So you have to do all the things that I'm telling to you, and you have to balance all the other subjects also, right? Because if you get an A for physics and S, you will not be selected, right? Maybe, right? So this is not a good results, right? So you have to give some not equal balance, right? You don't want to give your equal for all the exam, all the subjects, but you have to give some, right? So in here for physics, you just do whatever I say, right? That's it, right? No problem, right? You can just um, uh, get rid of your planning, right? So in the levels, I know the very hard part is like a plan in the next few days what I'm gonna do, right? So for physics, if you join with me and do whatever I say, then you can get rid of that planning and you can be free, right? So you can be free and just do the task that I'm giving, right? So that is it. When at the levels, you will be able to get good results, right? So that's the and that is the thing. And for other subjects, if you don't have a good guide from your mentor or your tutor, so you have to plan it very hardly, I mean very well, right? And you have to do that, right? So that is the thing. And you have to do all the things, right? That necessary to do. So start today. I mean, you have only 4 months, so it's already somehow late, but it's manageable, right? You can do 4 months, or you can do next. You can, I mean, you can work hard in just next 4 months, and you can try to do that one, right? Try to do your best, right? So you will be able to get the best result that you can get, right? So that is the thing, right? Okay, so let's talk about the physics now. The only I'm talking so much about the A levels and how to do it because this is the first day, right? In next days, I'm not going to talk about talk like this, right? I'm just only talking today, and maybe a few things later, but not like this, right? Very few means for the motivation, right? Today is the first day, so you have to get motivated, right? You have to start a big journey now. If you are in a journey, it's not a problem, but if you are not and you have missed a lot, so you can start now, right? It's not a problem. You are already late, but you can, right? But you can do this. There is a chance, right? Don't think I'm already lost and I will do it in second chance. No, no, no. There's a chance. You can do it in this first chance, right? Okay, maybe this is your second chance already, but don't go for third chance, right? You can do it now. You can do it this time, right? In next 4 months, right? So don't think you can't, right? Right. So that is the thing. Okay, let's get into the physics, the mechanics. Okay, let's talk about motion. Okay, the first correction, right? First correction is, let's talk about the first correction. Okay, the first correction is there's a uh, car. Okay, I will give you the correction now. So write it down and try to do it. I will give you like 1 minute, right? Let's try to do it. A car is moving 2 ms minus 1 2 meters per second for 20 minutes, right? In a straight road. Find out the distance the car will travel. At the end, uh, after 20 minutes, right? So 20 minutes, right? 2 ms minus 1. So the formula that we are going to use for this one is this is the first formula I'm going to teach in this A-level course, right? So it is S equals UT, right? So car is moving 2 ms minus 1 for 20 minutes, right? So 2 ms minus 1 is the velocity, right? What is velocity? Velocity is like speed, right? You know speed, right? Yeah. You look at the speedometer and say speed is 70 kilometers per hour, like that. So this is something we commonly use in science, in physics. Ms minus 1, that means meters per second, right? So the velocity is denoted by u, right? So u is 2 now. So s equals 2 into t. T means time, right? So in here, time is 20 minutes, right? So time is 20 minutes. 20 minutes means 20 into 60. Why? 1 minute. 1 minute equals 60 seconds, right? So 20 minutes equals 20 into 60 seconds, right? So this is equal 0 into 0, 6 into 2, 12, and there's 2 zeros, so 2 zeros going to be here, right? Um, so now this is 1/200 seconds, right? So t, we have to substitute t as seconds, right? 1/200. So always substitute t as seconds, u as ms minus 1, right? Always do that. And s What is this? Is this distance here, right? Or maybe we can talk like displacement, right? So what is the difference between distance and the displacement? So it is like this. Imagine your house is here and the food city is here, right? So you're gonna buy a Wonder Bar, right? So you are very hot today and you want to eat some ice creams. So you're gonna take a Wonder Bar and just come back, right? So this is your road here. Okay, so over there's a jungle, right? There are trees, right? And so you cannot go there easily. So you follow this path, right? So you come in this path like this, like this, like this. Okay, finally to the food city, and you follow the same path to go back to your home, right? So you go here, right? So uh, this road have a length like let's say 70 not 70 750 meters, right? Okay, so you have to if you follow this path, you go 750 meters. That is the length of this road, right? Okay, so length of the path. So this is called what? This is called distance, right? So whatever path you take, the length of that path is called distance. But what is your displacement now? The displacement is something different. What is that? That is how far you have displaced. That means the the straight line distance, right? That is this. That is like if you so if you want to measure the distance, you have to measure the path. But if you have to measure the displacement, you have to get the starting point and match the ending point, right? So to reach the food city from your home, you have to follow this path. So you have to go a distance of 750 meters, but displacement is the length of this line, not this line, right? This is the shortest distance, right? This is the straight line distance, and it called displacement. That is maybe like 400 meters, right? Maybe, right? So whenever you someone asks the displacement, you have to get the straight line from the start to the end point, right? So the length of this straight line is displacement, right? But length of the path that you followed, maybe it's a straight line, maybe it's a curved line, maybe it's a line like this, right? Whatever line, the length of that line, that path you followed is called distance, right? Right. So the distance is path dependent, but displacement is not, right? Okay, so in here, since we followed a straight line, uh, just to go in one direction, we can set this as displacement, right? This as displacement, no problem, right? So actually, in these motions, we mostly talk about displacement, right? Because we talk about straight lines and we talk about one directional motion in most of the times, right? Okay, so displacement or a distance here, or the distance here is 2 into 1, 200. So it is like 0 and 0, 4 and 2, 2400 meters, right? So that is the displacement here or distance, right? So the first is over, right? Oh, I forgot to give you 1 minute, right? So in next one, I will give you the 1 minute to solve this, right? Okay, let's go to the second one. So the second one is like car traveled 750 meters to north in 25 seconds. Find the speed of the car. Okay, so you have to find the speed of the car, right? So what is the speed? Again, you have to use S equals UD, right? And you have to find U. So you have to substitute s 750 equals u into t is 25 seconds here, right? So u equals 750 over 25, right? So 30 ms minus 1, right? Okay, so you can get the speed as 30 ms minus 1, right? So that is the speed, right? So let's go to the third question. Oh, I can forget, right? To give you time. Okay, this time I will definitely give, right? Um, okay, the third one is like a traveled car traveled 75 meters, sorry, meters. Um, the speed, the several meters um, to reach, not 75, 7,500 meters to reach next town. If the car travels at 20 meters per second, how many seconds will it take to reach the next town, right? So this is also a question from S equals UT. So you have the distance here, sorry, you have the distance here 700, sorry, 7,500 equals 20. U is 20 here, right? Into T. T equals 750 over 2, right? Because 0 to 0 you can cancel out, right? So T equals 7 divided by 2 is 3, and 15 divided by 2 is 7, and 10 divided by 2 is 5, right? So this is the second. How many? 375 seconds, right? Okay. So this is like if you want, you can get how many minutes, right? So 375 seconds, right? So 1 minute mean 60 seconds. So 775 seconds over 60 means how many minutes here, right? So you can find out how many minutes using this, right? Okay, but here they don't ask how many minutes, so we don't want to do that, right? So you can give the answer in seconds, right? Okay, so the fourth one. Okay, so now you know S equals UT. Okay, so S is the displacement or distance, right? And U is the speed or the velocity. Velocity means what? Velocity means speed in direction, speed with direction, right? So in here, we normally talk about motions in one direction in a straight line. So speed and velocity is like same term here, right? But in general, it's not the same. Speed is something don't have a direction, right? Velocity that always have a direction, right? Okay, so normally we can say speed like 20 ms minus 1 uh, if a car follow this way, right? But velocity is not like that, right? We have to say the direction. Okay, so if car is going like this, velocity is changing, right? Whenever the direction change, the velocity is changing, but throughout the whole journey, speed is 20 ms minus 1, but velocity is not, right? Okay, but for a straight line in one direction, it's like same, right? So T, what is T? T is the time, right? So the thing we have learned here, so we have to start fourth question, right? Okay. In fourth question, I will definitely give you time, right? Okay. Fourth question, a man walks into the train station from his home as following, right? So from A, this is the home, and to the train station, this is the train station, right? Right. So man followed this way. Go to the clock tower first. This is clock tower, right? And then goes to the train station, right? So for this to this, A to clock tower, home to clock tower, it takes 10 seconds. And clock tower to the train station, it takes 30 seconds, right? Right. Okay. So that is the, oh, I'm sorry, 100 seconds and 300 seconds, right? Okay. So you have to find uh, the speeds at these sections, right? And the average speed also. So, and the displacement, final displacement, right? So the first one is the speed at A to clock tower. Second one is speed from clock tower to train station. And third one is average speed. Fourth one is the displacement, right? Okay, so I will give you like, I'm going to give you like 1 to 2 minutes to try, right? Okay, just try now. Right. I think you have tried this, right? Okay, I'm going to solve it. Right. Okay. So speed uh, A2 clock tower, right? So you have to use S equals UT. So from the clock tower, oh my God, I forgot the meters, right? I'm so sorry about that. So you, okay. So from here to here, it's like 20 meters. And here to here, it's like 25 meters, right? Okay, I solved it. So 20 meters equals u into 10 seconds, and so u equals 2m is minus 1, right? So that means the speed is 2, right? So for this one, the second question, clock tower to train station, is like s equals u. We're going to use s equals ud, and 25 meters and equals to u into t 300. Oh, here is, oh my God, sorry. here it's 100, right? 100 seconds, right? So it's like 0.2, 0.2 m is minus 1, right? Okay, so right, so here u equals here 300, and t equals 300, and u equals 25 over 300, right? Okay, so let's get the answer, right? 25 over 300, 0.83, right? It's 0.083, sorry, right? And that is m is minus 1. And the average speed, okay, so how to find the average speed? Average speed means total distance, right? Total distance over total time, right? So that is the average speed. So it's also is equals UD, but here we have to use total distance. Here we have to use total time. So total distance is how much? Oh, it's 55 minutes, right? And u and the t is right 400 meters, right? So u is equal to 55 over 400, right? So it is like 0.1375 ms minus 1, right? So that is average. See, here 0.2 and 0.083, but average is in between that, right? 0.1375, right? Okay, so that is the thing, right? Okay, let's get into the fifth question, right? Okay, let's get into the fifth question. Okay, let's talk about the fifth question here. Okay, before that, we have to talk about displacement, right? Okay, so displacement is starting point to the ending point. We have to draw a line, a straight line, not just line, a straight line like this, right? Or not this, sorry, like this. Okay, okay, right. So we have to find the length of this line, right? So what is that? What is the length? Okay, you know we have to use Pythagoras theorem here, right? How to use Pythagoras theorem, right? Um, it is very easy, right? So what is Pythagoras theorem? That is like if we have uh, like this and 90 angle from this one, right? Wait, and something 90 angle from this one, right? Like this. And if you want to find the distance, the length from here to here, we can use the Pythagoras theorem, right? Because here it is 90 degrees, right? So actually in the Pythagoras theorem, we can find out if there's A, B, C. We can find out the length of the uh, line in front of the 90-degree angle if we know the other two lengths of the lengths of the other two lines, right? So if you know AB and AC, sorry, not AC, BC, we can know AC. So the if okay, let's put simple A, simple B as the length. So simple A is the length of this one, simple B is the length of this one, and if we say C is the length of this one, we can find out C squared, right, equals C squared as this. How? A squared plus B squared, right? So if we want to take C, if you want to get the answer for C, C equals A squared plus B squared and square root, right? So here Actually, we want to find the AB, that is like C, right? So the displacement. So here, the displacement equal to what? The displacement is equal to A squared B plus B squared. That means here it is like 100 is not 100, 20 squared, the length, right? Not the time. Length 20 meters squared plus 25 meters squared, right? 20 meters squared plus 25 meters squared over, not over, 25 squared. We have to add them and get the square root of the answer, right? uh, the sum, right? So 20 square is 400, 25 square is 625, and if you want to take the square root of the sum, it will be like 400 plus 625, 1025 square root of 1025, and square root of 1025 is equal to 32.01 6, right? Okay, so this is the displacement. So in here, totally, see the total distance is 55, but the displacement is 32. See, so those are different, right? So the length of the path he followed is 55. That is distance, but the displacement is different than that. See that this thing I told you previously, right? So now you can see it in this collection, right? Okay, okay, right. So that is the end of fourth collection. Okay, let's get into the fifth collection, right? Okay, so fifth collection. Let's talk about something bit different, right? But that is also about a car. A car is moving 20 meters per second for 20 seconds and reached to point A, right? From point A car start to accelerate. What is this? What is this thing? Let's talk about it, right? Start to accelerate. What is that? Start to accelerate. That means change the speed, right? Accelerate means change in the speed, right? So start to accelerate and hit 30 meters per second in 10 seconds, right? Okay. So the first question is find the acceleration, right? So acceleration is like how much speed change per second, right? So I will tell you how to properly find out the acceleration, but you can try now, right? Because you know the idea. And you maybe you have learned this one from your studies, previous studies, maybe all levels, right? Or maybe uh, somewhere else, right? You have learned this. Okay, find the acceleration. So second one is find the distance of all travel, right? Okay, so those are the questions. You have maybe 2 minutes to try, right? Okay, okay, start now. Okay. I think you have enough time to try. Right. Okay. Let's talk about the acceleration. Right. So a car moving 20 meters per second for 20 seconds. So there's no acceleration there, and reach to point A. So until point A, there's no acceleration. From point A, car start to accelerate and hit 30 meters per second in 10 seconds. So when it start to accelerate, the initial velocity is um, 20, right? Right. So the thing here the thing you have to know is u equals 20, right? So u in the s equals ut, u means velocity, but now since there is an acceleration, we just tell u as the initial velocity, and we have another new letter v equals the final velocity 30. So the initial means before the acceleration, right? Velocity, sorry, v means after the acceleration, right? So before the acceleration and after the acceleration, right? U is what? U is before, right? And um, and v is after the acceleration, right? V is what? After acceleration, right? So the next not question, the formula that I'm gonna teach you is v equals u plus a t, right? So what is this? V is the velocity just after the acceleration. We call it final acceleration. Final is not acceleration. Final velocity. U is the velocity before the acceleration, just before the acceleration. That means that called initial acceleration. Initial, not acceleration, velocity, right? And a is acceleration, right? Acceleration, and the time is t, right? As usual, right? This is time. So this is the second equation that you gonna learn. Okay, so in this case, v is 30. So we applying v equals u plus 80, right? And the thing is, in these formulas we have to mention the direction, right? We using this formula in this direction like that, right? So in here we just assume in direction is in this way, right? Because it is not mentioned, right? But um, uh, uh, whole motion is in one direction, right? Because they don't mention a direction change here, so we can use this, right? I mean, we can use a random direction like this. Okay. And they didn't mention the direction, so we can use a random direction like this for the whole motion, right? So 30. So as a practice, you can use this direction, right? Okay. So 30 equals u is 20 plus a into t. So in 10 seconds, right? So t is 10, and then you can find out 30 minus 20 equals a 10, right? So 30 minus 20 means 10. Then we get this 10 here. So 10 over 10 equals a. So the acceleration is 1 here, right? So 1 ms minus 2. This is the unit, right? Ms minus 2 is the unit. Okay, right. So a equals 1 ms minus 2. That is the acceleration. So that is the rate, the speed, the velocity is changing. So velocity is this. What is the meaning of this? The velocity is changing 1 ms minus 1 per second, right? So uh, in 1 second, velocity is, if velocity is 20, in the next second, let's see, like this is t1, and t1 plus 1. When is t1 plus 1, right? The speed is 21 now, right? Because it is increasing by 1 per second, right? So when t1, when time goes to t1, from t1 plus 1, velocity is going from 20